Hello, everyone. Welcome to Neural with Mohit. And we are going to continue our series where we were developing each component of RAG one by one. So, as you can see that we have already completed the text embedding. Right. Then we actually completed the vector DBs. And after vector DBs, we also learned that what are re-rankers and why do we need re-rankers, right? So today we will be developing the fourth component, which is integrating the large language model to our top results that we have received from the re-rankers. And what we will do today is we will develop the complete code right from scratch today, right? And we will try and cover all the elements so that you will understand the complete rack system altogether at once, right? And my advice would be to first go and see these videos. These videos you have to, go and see first so that you will be able to understand each and every component as and when we are going to develop it. Okay. So now before we jump into code, let us first understand the architecture of the application, that how the application is going to, be written, so that when we will discuss, you will be having that blueprint in your mind already, that how we are going to develop the application. And as a developer, this is the way we should always go. Before you jump into code, what you need to do is you need to break down the bigger problem into the smaller problems and then try and connect each and every component of that problem to generate the results for you. Okay. So let us come here. As you are aware that retrieval augmentation generation generally have three parts, right? Number one is where you actually create the document, right? Number two is where you do the query and retrieve the document results. And number three is where you generate, right? So one and two we have already seen. Third is what we are going to see today. Okay, so let us understand how the application is going to work, how we are going to develop the code. Okay. Okay, so we will be having document, right? And what we will do first is extract, transform, and load, which is like we will extract the information from the document. We will transform it to our required thing, and then we will load it to our object, right? And after we load it to our object, what we are going to do is we are going to do the chunking. As you're already aware that in this series we are doing a page level chunking. However, if you want, you can do any kind of chunking that you want, and we have discussed all the different types of chunking during text embedding and vector DBs, right? Okay, so after chunking, we will give it to an embedding model, and we are using here the text embedding model because this is currently text track, right? After the embedding model will generate the embeddings, what we will be doing is we will be storing those embeddings to our vector DB. Okay. So till here, everything is, sorted. This is the one-time thing that we have to do for each new document. Now let us come to the part where the user will start interacting with your application. So when user will send you a query, what you will first do is you will use the same embedding model and generate embeddings of that query. And then you will make a search. Right. First, we will check in our local cache if that query is already existing because when you're going to build an application, you will be building it for thousands of users. And let's suppose many of those users are working on the same PDF. There is a very high chance that the query also that they will make, will somehow be very relative to each other. So there, what we can do is we don't need to make a vector DB call. We can return it from our local cache itself, right? But if your query is unique and it is not present in your local cache, so in that case, what you will do is you will send, sorry, in case of cache miss, you will be hitting the vector store, ChromaDB, right? And from there, we will be getting the top K results. Those top K results first we will store in our local cache, and then we will check that if the query that we have, in our local cache, the result that we have the same query, do we have a matching query in ReRanker as well or not? If it is not present, then give those top key results to the ReRanker along with your query, and then ask the ReRank to do the sorting again. And from there, from that sorted result, what you will do is you will actually extract the top Y results from there, right? So top K and top 5, how it is, like let's suppose from vector DB, you extract 100 search results. From the re-ranker, you might be sending only top 10 of those, right? And then before you give it back, you will be storing it to re-ranker cache. And after that, now this is the new part that we are going to do today. We will be giving these top 5 results to our LLM. We will be sending a prompt along with that, and that prompt will be mainly, to take the result, humanize it, and then return, right? So we'll be using the prompt from the LLM, and then that we are going to send in the response, right? So this is how the architecture of this application is going to be. Okay. So now let us jump to our code. So here we have our code, right? And what I have done is, you remember from our first video, that I was using the Groq for the LLM. So what I did is I have created the Groq key and all, and you can also do the same. What you just need to do is you need to come over here, right? And you need to come to console.groq.com/keys, and here you need to create new API key. After you have created the API key, just copy your API key and store it in the env file. So here is the env file. So you will be storing it in .env file. And what I'm doing is I'm importing the operating system and I'm importing the load.env, right? And from there, I'm calling the load.env. And once I call this, what will happen is it will load the environment variables for me. And I can use this to extract my environment key. So in the .env file, I'm storing my key with this property. Okay. And once I do that, so you can see that I'm able to load it and I'm able to print it as well in my. Uh, okay. Now let us come to the to further implementation. So as you remember, first task that we will be having will be to first import the libraries, then extract the documents and everything. Right. So what we will do is we will do the step one, which is import libraries and load the document. Okay. So this will be a step one. So we are going to do the same. So these are the libraries that we are going to import. We will be using the PDF plumber. So we are importing that along with that sentence transformer, cosine similarity. All this you can recall from our previous videos itself, right? So I'm just loading this library. It will take some time to load, right? Once the library is loaded, we have our document over here, right? So what we will be doing next is we will be loading a document and we will be checking all the pages. So we can see that we are able to load a document. This is the complete path that I've given for my document. I'm going one step below in my directory, right? Because I'm here. So I have to go to my parent directory first and then I have to go to data. So that's why you see this dot dot. Okay. So now the document is loaded. I can see that it has 142 pages. And if you're following the rack series, you know that the document that I'm using has exactly 142 pages, right? So now what we are going to do is we are going to do the chunking, right? So first, what we will do is we will, create the chunking strategy for us. So for that, we will be creating an array subs first, right? So we'll be having the text content and this, right? And then we have written a function where what it was doing is, like if the number of characters in the page is more than 5,000, so I was splitting that in two parts, right? That whole page I'm splitting in two parts, and then I'm storing those, right? So if you remember that code. Okay, so this is the code that we have already done, so that's why I'm doing the copy pasting over here. So you can see that we have the find the middle line, which is like, from that complete content, get the middle of that, and then, divide it in two parts, and then, and we are doing this based on the backslash n only. So, like for the new line, we are checking, right? And based on that, we are dividing the content, right? And here is the logic that I was talking about. So what we are doing is we have loaded all the pages of the document. So from there, what we are first doing is we are going through each and every page. And in that page, we are checking that how many characters are there. If the character length is more than 5,000, in that case, we are calling our function to, split the page in two, and we are storing it as two parts, where we are putting split as 0 and 1. Otherwise, we are putting split as 0 and the page number here, right? So this is how we are implementing. Let us run this. Let us see that what do we have here. So it is currently running, and you can see that we are going to, fill our table content, and we are able to see that the data is there. One more thing that we did is we are only acknowledging the pages where the number of words are more than 10. So if the number of words are less than 10, then we are not acknowledging that page at all. Okay. So till here we are done. Now, what is the next thing? If you remember, next thing that we were doing earlier was we were creating a data frame from the document that we have. Right, I don't need to do this. And from that data frame, we were creating a metadata column, right, based on our document. And then after that, we were printing it. So you can see that I have the content and I have the metadata, and each metadata will contain a page, split, and the type, right? And since we're using only text, so all the types will be text only for us, right? Okay. After this, what we were doing is once we have the document, then the next part that we had, if you remember the architecture, so we did the load the document, we did chunking, right? Now, next, what we have to do is we have to convert it to text embedding, right? So let us do the code for that. So let us go through the code once. So we have the model here. This is the model that we are using in our series, right? And then what we are doing is we actually loaded the model. We have given the content, and then we encoded all the content, right? And we also have created the IDs, and the IDs are created based on the document, page, and the split. So each page, because our chunking is based on the page level, and if the characters are more than 5,000, then we are splitting the page in two. So that is why our IDs will be unique for this, right? So let us create this. It will again take some time for you to create. And after this, what we will do is we will load our ChromaDB. Again, we have the store already available, so you don't need to do this again, right? So here, when I will run this, so we already have this. Our ChromaDB will be loaded. And if you remember the code, it is like if the collection already exists, right? So in that case, we will directly load it. If it is not existing, only in that case, we are creating it, and then we are adding the content to our ChromaDB, right? So one thing that we will do in this is for each document, we will create a new collection name. Okay. So that this logic that we are writing over here remains intact. Okay. Now let us. So till here, if you have done, so if you remember uh, in our architecture, so this part we already did, and you can see that it is a very simple part, right? So we extracted the document, we did the chunking, we created the embeddings from the embedding model, and then we stored the embeddings in the store, right? Okay. So now what do we have to do next? The next is, where user will be asking a query, and we will be searching the results. But to do that, what we need to do is we need to create a search logic, right? So let us create a search logic. Let me also add a markdown here. Right, and let me just add a markdown for each and everything that we actually did so that we don't forget. So here, if I'll come, we have added the. So here we have added the what we did. We chunked, right? So chunking, and we are doing the page chunking on this, right? So page chunking is done here. After this, in this, once the page chunking is done, then we created the data frame, right? And then here we did the oh, step three, and we did the embedding on this, right? So here we perform the text embedding. Basically, I write text embedding because you have multimodal embedding as well, where you can create image embedding, audio embedding, video embedding. So it's better that we specify it properly. So step three is text embedding. So we are done till here. Now, what is this? This is the logic to search. So here what we are doing is step four, and this is DB search, DB slash cache search business logic. Okay. So here, let us understand this logic also once. Oh, sorry. Yeah, this is not that. This is sorry. After the text embedding is created, we are storing it to DB, right? Store the embeddings to DB. Okay. So this is done. Now the fifth step is actually step five is basically where we are, writing a search logic for DB slash cache. Okay. So we are done till here. Uh, And if you see that we have all the things that we need defined over here, okay, so this logic is we are able to run this, and let us just go through this very quickly, although you must have already seen in the previous video, so I'm going through this very quickly. Okay, so what we are doing is we will give the query to this. So first step is to encode the query, and if you remember the architecture, when the query comes, first we give it to embedding model and we create the embeddings for this, right? So we will create the embeddings of this query, and then we will check like a cosine similarity search in our cache. If that query is already existing, then we will return it from there itself. If the query is not existing, in that particular case, what we will be doing is we will be making the DB call, right? And you remember this logic here. If it is in cache, return from there. If it is not in cache, make a DB call. Okay. And after that, we will store it in cache again, which is storing in cache again, right? And then returning the results to whosoever is calling it. Okay. So we are done till here. And when we will, make a query, so what will happen is first, this will give us a similarity score and results, right? And those, what we will be doing is we will be sending that to the re-ranker, right? So you remember that those results will be sending to the re-ranker. So now let us write the re-ranker. So first we have created a dictionary, and then we will be writing the re-rankers over here. Okay, so re-ranker code also you must remember that what we do is we actually let us do one more thing in the re-ranker. We will be sending the similarity score, and we will be sending the return query as well. Okay, and let us send this as second and third argument. First will be query. Okay, so we'll be calling the re-ranker, right? And from there we will be having all the results and everything. Okay, and from the results we'll be doing all these. So we'll send the results also to this. Sorry. Cool. So here what we are doing is in this function, we are passing the query, we're passing the similarity score. This similarity score will be, from the vector search API. Then we will be sending the return query, and we will be sending the result that we have received from the vector DB search. Okay. So I'm just going to run this. So now the function is created for us. And now what we have to do is whenever you get the result, so you have to make the query. After you do the query, you will get the result. You will get the top five results. So let us do that. Let us first make a query and then go for the results. So let us make the vector DB search first. You remember this was our query last time. So what we will do is we will make the query first. And once we do the query, after that we will be, getting the top five results. So I would say top five is equal to re-rank results. And here, what do I have to pass? I have to pass the query, right? I have to pass the similarity score. I have to pass the return query, correct? And I have to pass the result. And if you see, I have all these details already extracted from our vector DB. Okay. So we have the top five results, and these top five results are the ones that we are going to use now for our what we say. And let us just print it also so that we will at least have some idea that what we have received, and we will brush up some of like it will brush some of our memory. So I'm just saying, let's suppose 50, or let it be 100, right? 100 characters we'll be printing. Okay, so this time what it will do is it will first make the DB call, and after the DB call, it will get the top five results for you. And from those, it will do the re-ranking, and it will give you everything like page number this, content is this, and kind of, it will be printing all this. Great. So we are actually done till here. Now what we have to do is this part, right? So this part is what we are going to do. Okay. Okay, so now let us do the most important part of the RAG, which is dealing with the LLMs basically, right? So here, what we will be doing is we will be, opening the LLM in this. Okay, so let us do. Uh, Now comes the most exciting part of this tutorial. Okay, so great. So we have the results, and what I will be first doing is I will be taking all the result content. Okay, and I will be creating, something like a kind of results for me where I will be adding a page, and like the page number I will be adding, and I will be adding the text content, that what is the text content of that. Okay, so first let me create that. So I will say all results is equal to, I'm just going to create a simple string. Okay, and what I will do over here is the same thing that I did here, which is like I will, iterate it one by one. And then first thing what I will do is I will say, let's suppose my var is equal to, okay, and let me do it like this. Okay, and here what I will be doing is I will be, uh, let it come here. Okay, so here what I will be doing is I will be first adding something like this, and then I'll say, and yeah, before that, let me just make it a F string. Okay, and I will say page number. Okay, and page number will be our page number like this. We can extract. So we will be extracting the page number here from the meta, right? And then the next will be in our this text content, right? So we will be having the text content, and in the text content, we can simply extract it like this, right? And this time I will not, select a particular that. I will be giving the complete to this. Okay, and then each I will be adding this. Okay, and then after this, what I will be doing is I will be saying all results equal to backslash n dot join, and what I will be joining is Okay. So basically, I can just write it very simple way also. Just one second. Why to complicate with unnecessary functions and all, right? So let us do it like this. You don't need any of this. Okay, so what my all results will be? All results will always become, the all results and then backslash and then this. So it will be assigned to all results again, and every time, like when it will go, so all results will keep on appending with this new detail. Sorry, my throat is, not that great, and I'm having some uneasiness while speaking. So pardon me for that. Okay, great. We did this. So after this, what I would like is I would like to print all results once so that I will know, what is the value here. And you can see that it is going like this, text content, we are having this, correct? So you can see that everything is created in this, okay? And we are able to like extract each and every detail. That is great. That is great, really great. Okay, so now what should we do? Now our next plan should be to, provide it here, right? So instead of this, let me just do this thing so that it is a bit easy thing to, operate with. Okay, so I have this now, and my prompt is this. So if I'll execute this prompt, so you will be able to see like the prompt is created with all these details, right? And at the end, after all the details, it will be like inserting the document. So here is the document that it has inserted, right? So this is how we have all the details that we need. Now, what is the next task for us? The next task for us is to pass this to the LLM, and then the LLM will be using it. So we have already created a Groq key. If you remember, in the very beginning we have created this. Here we have created the Groq key. So here what I will do is first I will create the LLM, right? So I will say create the LLM, right? I'll add the steps later because I, lost track of how many we have added and all, and there are a few left also. So in the interest of time, let me add it later. Okay, so we have this, and now what we have to do first is we have to, create a Groq client. So this is how we are going to create a Groq client, and we also need to import the Groq. So let us do one thing. Let us import it here itself. Okay, great. So we have the Groq client here, right? And if you remember last time, sorry, yeah. So if you remember last time we were creating what we say the Llama model, right? So we will be using the same Llama model this time as well. I'll do a few changes. So I do not need this. I will remove this. Okay. And in the content, what I will do is I will simply pass my LLM prompt. Okay. So this is what I'm going to pass here. So now my prompt is there and I'll be giving all the detail to this. And after this, we will run it. Okay. So let us run this. Let us see what happens. It will take some time. And now we have the result, with us. So what I will do is I will create a function to actually, uh, like, I'll create a function to actually create console here. And okay, I've done that. And then let us print the result and see what do we have here. Okay, there is some error. JSON.
Okay guys, so yeah, so we were working on this, and here we were getting this error. So as you can see, it is saying that name JSON is not defined, right? So we have used JSON in this function, so that was not defined. So what I've done is I've exited the JSON, and I've also added the markdown, right? So let me just rerun it and then run it again. And now what you will be noticing over here is that on our query. So let me just do one thing. Let me like write it like this so that it is more understandable for you. Okay, what's the revenue of use? Uber. Uber's technology has released its fiscal year this blah 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 statement shows the significant increase in revenue from 31.9 billion in 2022 to 43.98 billion in 2024. This growth can be attributed, and if you see, it is very humanized for you, right? Like when you were getting it from the document, you remember from the previous tutorials that the language was very bookish, right? But when we gave it to the LLM, so now what it is doing is it is actually kind of summarizing it for you and giving you back, right? And you can also add in the prompt that along with this it should give you the page numbers also. I can say here, uh, also give me the reference page numbers. Okay, so let me just make this prompt again, and let me just hit the LLM again. Okay, and now let me just add this. Okay, so what this will be doing now is you will notice that Uber Technologies include has released this the result will remain same, right? This in 2024, and see it is giving you that this is from the page number 79, right? And it is giving you this over here and telling you this is from the page number 51, right? And it is at the end, it is also giving you all the reference pages from which this data has been collected, right? So this is the power of RAG, where what it does is your queries, it actually gives you a very humanized response. You don't need to go through the document at all. You can just simply ask questions here, and you will get your responses basically, right? Like for each item, so what we are doing is we'll be doing the vector db search. We are getting the response, and once the response is there, those responses you will be giving to LLM with your prompt, and the LLM is going to give you the result in which in a form where you can very easily consume it, right? And that was the whole goal of building the rack system for us. So if you remember, we were till here in the previous tutorial. From here, now what we are doing is we are giving this result to the LLM along with the prompt. So basically these results are added to the prompt, right? So what you can do is like you can instead of this you can add it like this also. Okay, so basically what you are doing right now is you are actually sending these to the prompt, and then that prompt you are giving to the LLM, and then the LLM is actually generating a response for you, which is a very humanized response that you have noticed over here, right? So this is how the rack system works, and now you have the complete understanding of all the components which are there in the rack, and you also understand that how the internal working of the rack happens, and which components contribute to what part of the rack system. So we have actually done with this text rack. Now the next we'll be going through the multimodal rack, right? So if you have liked this video, I would say like it on YouTube, share it with your friends so that they will also learn about the rack, and also subscribe to the channel. Thank you.